Hi. So previously we've taken a look at single subject GLM analysis. In this module, in the next, we'll start talking about group level analysis, i.e. the analysis of multiple subjects. Though we so far focused on single subject analysis, fMRI experiments are often repeated for several runs in the same session, for several sessions on the same subject, and for several subjects drawn from a larger population of interest. These types of multi-session, multi-subject experiments may increase the sensitivity of the overall experiment as more data is available for study. They may also allow you to determine whether the observed effects are common and stable across or between different groups of subjects, such as cases or controls. And also, they may allow for generalization of your conclusion to the entire population of subjects from which your subjects were drawn. This type of multi-session, multi-subject experiment provides data that is hierarchical in nature with lower level observations nested within higher levels. Here we see an illustration. We have a group which consists of n subjects. Each subject was brought in for m different sessions, and within each session the subject performed a run k different times. Each run consists of a series of three-dimensional brain volumes as illustrated below. Now this hierarchy can be extended. Let's say that we have multiple groups, then we can add a layer. Multi-level models have been specifically developed for analyzing this type of hierarchically structured data. Now these types of models allow different variance components to be introduced at each level. So we have within subject variance and between subject variance if we have a two-level model. These types of models provide a framework for performing what's called mixed effects analysis. So, when you're reading the fMRI literature, you quickly come across two types of analysis when speaking of group analysis. And so we often discriminate between what's called fixed effects analysis and mixed effects analysis. People sometimes also talk about random effects, but it's become kind of synonymous with mixed effects. And so these types of analysis differ in the type of assumptions they make, and also which types of conclusions that they provide. For example, in a fixed effects analysis, we assume that the true response magnitude is fixed in all subjects. So we assume that all subjects in the study have the same beta value corresponding to some regressor which represents the signal of interest. Now the only source of variation is due to measurement error. So the only reason that my scan is different from your scan would be due to measurement error when collecting the data. Significance is based on estimated response relative to measurement error variance, since that's the only source of variance. So any t-statistic is based on the beta, estimated beta, compared to the measurement error variance. Now fixed effects analysis, we're only interested in making conclusions about the subjects currently being studied. So we use this type of analysis when we're doing case studies. There's no difference between the subject per se, except for the measurement error. In mixed effects analysis, on the other hand, the subject level effects are considered random variables. This means that all the subjects in the study will have slightly different beta values corresponding to the regressor of interest. And these beta values are assumed to be draws from a random distribution with a population mean, but with some population variance as well. So now there's two sources of variation. One due to the measurement error, as in the fixed effects model, but also there's another one due to differences in response magnitude between subjects. So some subjects might have a higher beta value than others due to this between-subject variation. Now significance is going to be based on estimated response relative to both sources of variance, both the measurement error and the between-subject variation. However, because of that we've incorporated this between-subject variation, this leads to that the results are going to be more generalizable to a population of subjects. And this is important because we often want to make conclusions that are generalizable to large proportions of subjects, rather than just to the subjects under study. In some, fixed effects models show the effects seen in a particular set of subjects, so we often use these for case studies. Mixed effects models imply that sampling a new group of subjects from the same population would give similar results. So mixed effects models tend to be more interesting, but they also tend to be more conservative. However, we're going to focus almost entirely on mixed effects modules in the next module when we perform group analysis. Okay, that's the end of this module. Here we've talked about some of the terminology we use when performing group analysis, such as mixed and fixed effects analysis. In the next module, we'll talk about actual models that will fit using this kind of mixed effects framework. Okay, I'll see you then. Bye.